How can we describe rocks? It's useful to group rocks based on their properties, like size, shape, and colour, or even by feel, like bumpy or smooth. Some rocks have grains packed tightly with no spaces inside them, and this makes them quite heavy. Water can't get inside them. We call these rocks non-porous, and examples are slate and granite. But some rocks do have spaces inside them. We call them porous rocks. Water and air can get inside the spaces. The water inside them is called groundwater, and it's very important because we can use this water for drinking or watering crops. Examples are sandstone and limestone. Some rocks are hard to break, while others are soft and crumbly. A man named Frederick Mohs found a way to test rock hardness. A harder rock will scratch the surface of a softer rock. It's called a scratch test. Did you know diamond is the hardest rock and talc is the softest? Diamond can scratch anything, but talc, even a fingernail can scratch it. We use rocks for different things based on their properties, like slate for roofs because it keeps water out, or chalk for drawing as it wears down easily. How do volcanoes make rocks? Did you know volcanoes can make rocks? These rocks are called igneous rocks. Here's how. When volcanoes erupt, they produce magma, which is a melted liquid rock. Once magma reaches the Earth's surface, we call it lava. When lava touches the cool air, it cools down quite quickly and becomes igneous rock. These igneous rocks have tiny grains or crystals. Examples are pumice and obsidian. But not all magma comes out to the surface. Some stays underground. This magma cools slowly, making igneous rock with bigger crystals like granite. Did you hear about Pompeii? A long time ago, its volcano erupted and made lots of igneous rock. Unfortunately, many of its citizens died and were covered in ash from the eruption. Volcanoes are nature's way of creating and shaping our world with igneous rocks. Sedimentary rocks. Ever wondered where we find fossils? Rocks break into smaller pieces due to weather like wind and rain. These tiny pieces are called sediment. They can be as small as a tiny pebble or as big as a boulder. They travel through streams, rivers, and end up in oceans or lakes, sinking to the bottom. Over millions of years, they press together, hardening and forming layered sedimentary rocks. Rarely, underwater plants and animals can get trapped in between the layers of sediment, and they eventually turn into fossils. Different sediments make different rocks. Limestone from animal shells, sandstone from sand, coal from plants, and shale from clay. Though soft parts decay, hard parts like bones and teeth remain. But remember, fossils aren't the actual bones and teeth. Some fossils are even from footprints or animal waste. Through fossils, we learn about ancient life and climates. Metamorphic rocks. Let's dive deep into Earth's secrets and discover how rocks transform. Older sedimentary rock layers are buried deep, deep down under the earth or ocean. They're close to the heat from magma. They experience incredible heat from below and pressure from above. This intense squeezing and heating causes them to transform. They change into what we know as metamorphic rocks. Shale turns into slate, and limestone morphs into marble. But that's not the only story. Igneous rocks deep in the earth also have their own tale of transformation. When these igneous rocks experience heat and pressure, they too can morph or change. And you guessed it, they change into another kind of metamorphic rock. When an igneous rock like granite undergoes heat and pressure, it transforms. It can become a shiny rock called gneiss. So whether it's an old sedimentary layer or a deep-seated igneous rock, both can become the marvellous metamorphic rocks. These transformations show the dynamic nature of our planet and how everything, even rocks, can change over time.
Now let's learn all about the rock cycle.
Remember what we learned about metamorphic rocks? Well, that was only part of a longer journey called the rock cycle. To recap, heat and pressure can change igneous and sedimentary rocks into metamorphic rocks. But if we keep heating metamorphic rocks, they melt and eventually form magma. You might remember that when magma cools, it becomes igneous rock. Wind and water can wear away igneous rocks into tiny pieces called sediment. With time and pressure, these layers of sediment squeeze together to form sedimentary rocks. And we've been here before, if we heat and squeeze these sedimentary rocks deep in the earth, they turn into metamorphic rocks. And that is the rock cycle, from melting to cooling, breaking down, pressing together and changing. It may not look like it, but rocks can go through a lot of changes. Have you ever wondered what's under your feet when you play outside? That's soil. It's more than just dirt. It's a mix of broken rocks, dead plants, air, water, and even some tiny animals. Soil is really important because it gives plants everything they need to grow. There are different soil types like sand, silt, and clay. They feel different to one another and hold water differently. We can make sand castles at the beach. Sand has large grains and feels, grainy between our fingers. Sand doesn't hold water well. Pour water on it and watch it drain away. Next is silt. Imagine the flour-like texture, smooth but a little bit grainy. Silt can hold on to some water, making it a comfy home for plant roots. Lastly, there's clay. Have you ever felt pottery or wet ceramics? That sticky feeling is because clay has tiny grains. Clay loves to hold on to lots of water, but be careful. Too much water and it can get all waterlogged. Mix them in different amounts and you get various types of soil, but all have some features in common. On top, the bit we can see, there's the humus layer, rich with living and decaying plants and animals. Right under it is the topsoil, where plants have their roots and worms wriggle around. You might think worms are pests, but actually they have important jobs. Their wiggly movements make small holes or pockets in the soil. This allows air and water to enter the soil, perfect for plant roots. Dig deeper and you'll find subsoil. It's tougher here with more minerals and bits of rock. Only big plants like trees can get their tough roots into this challenging layer. Lastly, there's a solid layer at the bottom called bedrock. It supports all the layers above. So next time you're gardening or playing outside, remember these soil superheroes and the important roles they play.